Consider the following statement. The negative of any rational number is rational. Write the statement formally using a quantifier and a variable, and determine whether the statement is true or false and justify your answer. So first we should recognize that this statement is universally quantified, and what is being quantified are rational numbers. We're making claims about any rational number. So for part A, we will start by identifying a propositional statement, P of x, which I'll say x is a rational number. So now we could say for all r, if r is a rational number, then the negative of that rational number is rational, meaning I can input negative r into my propositional statement P, and that will be true because r is a rational number. So this statement is true, and to show that it's true, we're going to prove it. We're going to assume that r is a rational number. The goal is to show that negative r is a rational number. To get there, we can start by unpacking what it means for r to be a rational number. By definition of a rational number, r equals a over b for some integers a and b, where b does not equal 0. So the goal is to show that negative r is a rational number. So what I'm going to do is I'm going to multiply both sides of this equation by -1, which we can do because that's one of the fundamental rules of algebra. So by algebra, we could say that negative r equals negative a over b, and we could rewrite this fraction as negative a all divided by b. Since a is an integer, then negative a is also an integer. So now we've shown that negative r equals negative a divided by b, and the numerator is an integer, and that's because integers are closed under multiplication. So if we multiply a by -1, we still have an integer. We also have that b does not equal 0. And so by definition of a rational number, negative r is rational. And that's the conclusion that we wanted to show. Thanks everyone, and I'll see you in the next video.